Hi, thank you for the introduction. My project today is titled The Geography of Loss. I basically use Park Service data to explore mortality and risk in public lands. At a really high level, the project asks a pretty simple question. What can the data tell us about the risk? My name is Jessica Long. I'm a registered nurse with a background in emergency care, a wilderness first responder, and an Army veteran. More recently, I've been working in technical consulting and data workflows, and I'm actively pursuing purpose-driven data roles where analysis informs decisions. I'd love to help people and systems be safer and smarter. I'm based in Corbin, Kentucky, and I'm open to remote, hybrid, or in-person work. Because of my professional experience, I have spent a lot of time thinking about what happens when people get hurt in places where help is limited or delayed. When choosing a project, I gravitated towards data sets that could help look at these risks through a different lens than just providing emergency care after the fact. I started with the National Park Service's mortality data set, which documents all known fatal incidents from 2007 to 2024. Each record includes some basic information like date, time, location, cause, and demographics, and it covers all of the park units. So that includes historic sites, monuments, scenic rivers, essentially anywhere where somebody is standing in front of a brown sign with that arrowhead and they're thinking, yeah, it's hot, and yeah, I'm wearing flip-flops, but my water bottle is almost full, so it's probably going to be okay. After I cleaned that data set, I started with some exploratory analysis to understand what I was really working with. I found that the fatalities skewed heavily male, they trend older, and they most commonly involve drowning and car crashes. None of that was surprising, and the patterns align with what we see in other public safety data. So that helped validate the accuracy of the data set and understand what questions I should really be asking to dig into the risk behind the events. To understand the incidents at a deeper level, I needed more context. Based on the Park Service documentation, I expected all the data to be structured really simply. One park unit equals one four-letter park code that's used consistently everywhere. Spoiler alert, the data was not structured simply. In reality, a single park unit often maps to multiple codes depending on the data set. That made reliable joins impossible, and in some cases, it limited what data I could even retrieve because the APIs were looking for specific unit codes. At that point, this really stopped being a cleaning problem and it became a systems problem. So I had to take a huge step back and rebuild the foundation. I ultimately combined 8 separate Park Service datasets using APIs, downloadable files, and web scraping to construct a consistent, complete park unit key. Along the way, I added roughly 200,000 additional records that provide operational, environmental, and geographic context for each incident. This is the resulting SQL ERD, which is really the backbone of my whole project. At the center is a fact table with mortality incidents, and around it are dimension tables for park units, dates, causes, activities, demographics, and so on. I designed the structure to clearly separate what happened from where, when, and under what conditions it happened. That makes it easier to ask new questions or add new information over time without reworking the whole pipeline. I built this really intentionally to be a well-structured data warehouse and not just a one-off setup to answer a single question. When the database was designed, I wanted to determine the mortality rates normalized for visitation so that I could distinguish high volume parks from high risk parks. Raw counts didn't really work because the visitation varies so wildly. You have parks like Great Smoky Mountains, pictured here, which sees over 12 million visitors a year. And then you have places like Gates of the Arctic in Alaska that sees fewer than 12,000 visitors a year. So in a park with that level of traffic, a single fatal incident can make the risk look enormous, even if it was just a one-off freak event. To deal with that, I use an empirical Bayes approach to calculate a credible mortality rate per million visitors. In practical terms, that method asks how much information do we actually have before we decide something's risky? It tempers those extreme values when the data is sparse, but it still preserves the meaningful differences. And this chart shows the parks with the highest credible mortality rates per million visitors. The dashed line marks the system-wide baseline, which is one death per million visitors. And just for some context, if you look at the US population over the same time period, the average mortality rate's about 8,000 deaths per million people. So even the most dangerous parks in this data set are, statistically speaking, still orders of magnitude safer than daily life. But what really matters here is that the credibility adjustment did not erase the outliers. Even after accounting for visitation, some parks still stand out by a lot. Risk is not evenly distributed across the park system, and the credible rate helps surface where the variation is real and worth understanding better. When I calculated the credible rate for all of the parks, I used Folium to build this interactive map. What you're seeing here is a screen recording, but the actual output is an HTML file that users can explore on their own. You can zoom, pan, hover over parks to see details like the park name, the mortality rate, and the data completeness. And you can customize those pop-ups depending on the audience. Being able to move through the geography of loss this way makes the patterns feel more intuitive, and it naturally points to better follow-up questions. So from here, I have continued exploring relationships between the mortality rates and the park risks, but I don't have time to go deeper into that today. If this project sparked your curiosity, I would genuinely love to talk about it more. The QR code on the left goes to the full project on GitHub, and the one on the right goes to my LinkedIn profile. And you can just take a quick screenshot or a picture with your phone and save them if you want to connect. Um, Thank you all so much for your time today, and especially thank you to CodeU for the opportunity to share my work.